So this is lab 8 for rotating and balancing tires. The two of the most popular machines in the industry would be Coates, which is what this one is, or Hunter machines. The functionality and how they work is similar, all right? Most of your newer machines are pretty automated. They're taking a lot of the measurements that we need to do tire work automatically. The older machines, what they would measure and what we would input into those machines manually would be the tire width, or wheel width, where we would go and measure the rim width this way with a claw. We would measure rim width there, and then once it's mounted up to the spindle, they would want to know the offset, which we take with a data arm like this. So offset there. And then they would want to know the wheel size. And so we would manually input that sort of stuff into a computerized balancer like we have nowadays. The computerized balancers will do a static and dynamic balance. And so if you remember from what we talked about with wheels and tires, a static imbalance is just a heavy spot end to end, which causes tires to bounce or shake while you're going down the road and want to lift off the ground every time that heavy side comes up. A dynamic imbalance is where they have a heavy spot on one side of the tire or the other, and it makes them want to wobble. Most of the time when it's necessary to balance tires, we should be balancing them on a maintenance interval of about every 6,000 miles, or every other oil change in that regard, or if it's synthetic, then every oil change. The complaint that you'll get from customers when tires are out of balance is they'll say that their car shakes. And the question that I always have for them is, how fast are you going when your car shakes? Does it shake when you're driving around town, or does it shake at freeway speeds? And if they tell me it shakes at freeway speeds, then there's a good likelihood that their tire is out of balance. Now, understand, the wheel and tire both have to be balanced. So we balance the tire by stacking weights on the wheel. But everything in that drivetrain that rotates at wheel speed also has to be balanced. And so what else rotates at wheel speed with that tire? The tire mounts up to the hub of the car. And so what goes on the hub? A rotor or a drum. So that has to be balanced. What drives the hub? The axle. So CV axles and things have to be balanced. So understand, when you have shakes at freeway speeds, the wheel and tire is the most common. It has the most opportunity to come out of balance by hitting potholes and getting people locking up their wheels and scrubbing them, things like that. Getting flat spots on their tires has the most opportunity to get out of balance because of what it does and where it lives and the roads we have in California. But understand, all of those other things can cause the same vibration and shaking at freeway speeds. And I actually have fixed cars for shaking at freeway speeds for bad axles, for rotors or drums that were out of balance. So understand, everything that rotates at wheel speed also has to be balanced, just like the tire. And if they're out of balance, then typically we replace those components. But balancing tires is pretty straightforward. The functionality of this machine, piece of cake. The only arm that we have to move once we get this wheel mounted up to the hub here is we move this data arm out and it takes a measurement there. There's another laser measurement that takes place from the outside hood area here that takes an outside measurement, and then the rest is history. There's a few different settings on how we can set to balance this tire, which I'll cover a little later, but obviously the best balance is getting the weights furthest away from each other. The closer we go to center, the more of a static balance it becomes, and then the more weight you have to add to compensate. So if I had to add, 1.5 ounces to the outside over here, but I want to now move it towards the center of the tire and have another weight over here, I may be at 2 ounces to put the weight here versus 1.5 out here. So the closer we get to the center, the more weight you have to add on that tire to counteract any imbalance that it has. So mounting this up, there's a few different little mandrel cones that we can select from that are on the back here, but we've got, from this size small to this side's humongous for your big wheels. And so we're gonna select the mandrel that is necessary there. So we pick one, that one fits inside there, so that's the one I'll slide up on this mandrel. Then when I mount the tire up, I'm gonna slide it up onto that cone, and then get my wing nut and mount this up. So this wing nut's got a little lock on it that if I go here, then I'm at the threaded portion. If I go here, it retracts them to where I can just slide it up and then get to a portion where I want to lock it. So I'll lock this down nice and tight. And then the next thing that I'll always do is spin that tire and make sure that it's true. So I don't want to see it wobble. If it's wobbling, then it's not mounted up square and flush, and then I'll have to reset it. So that's mounting it up. Now we'll get to balancing it. So to set the rest of this up to continue to balance, you're going to grab your data set arm and move it to where you would place your wheel weight. And so it's going to grab a reading there, the machine beep, and so then we'll lower the hood and it's going to spin this tire. I always watch the tire as it spins. I want to step back and watch it so that I can see if it has any separated spots. So we'll go ahead and look for that, and you watch to see if it hops, if any of it separates. So it's done spinning there. So on this, if we remove our old wheel weight here and spin it again, I always spin them first to see how bad it is and see if they're out of balance. If you're ever chasing an issue for a tire that is out of balance, then you want to make sure that you spin them first and confirm that it's out of balance so that you know that you fixed your problem. So it's asking for 3/4 of an ounce inboard on this side and 1.25 ounces on the outside. Some of the stuff that you may not be able to see, but I want to explain it to you. C2, these are different weight locations. So I'm right now in a placement that is C2 and T1. So if I want to be at C2 and C1, that is the furthest out I can go. So I have outboard locations this way and inboard locations this way. So I can go to T3 where I would use a sticky weight on the outside, which this wheel in particular wouldn't support that. But I can go on, if I did want to hide my weights, then I go to T1. And so on T1, one of the things that you'll notice is that it's adding more weight the closer to center that I go. If on this one, it adds weight once I go away from there. If I go to T1, then it's gonna typically add more weight this more I go. And this is a patch on the inside of the tire is what that's showing and highlighting red there. If I go to T2 and inside, that's typically what you would do for nicer wheels where you don't want to see the wheel weight. Then you would hide it on the inside of my hub surface there to where you don't see any weights on the outside. And so to do that, you typically want to reset your data arms and index where you want the weight to go. And so from here, if I come in and grab my outside weight there, then my inside, I move in and touch it off where I want it to be. So I'll touch it off in there where I want it to be and then come back. And then what you'll do, there's a little laser inside here that you can move and adjust to point to where you want the weight to be. And so you'll line that up, and then that helps in your weight location and indexing on how far you're going to go. I'm set right now to do a dynamic and static balance. If I drop the hood again, I should get the same numbers since I've already spun it, because these machines are pretty smart. So yeah, same numbers. So that would be, that's something that can be done after the fact. I'm going to reset this back to C2 and C1. So I'm just going to come back and re-index this and spin it, and you can see it goes pretty quick. So then when it comes to weight placement, this little card right here has a variety of different sizes of or shapes of wheel weights. There's a chart that you can look up for different vehicles up for its stock wheels that will show what their factory wheel weight would be, whether it's an MC or an FN or IAW or AW and so forth. There's a variety of different wheel weights that you can have. If it's an aftermarket wheel, then you just match up the shape of that wheel lip or rim surface to a wheel weight and then see which one fits, just like Tetris. So these are P weights for your steel wheels. A lot of your aluminum wheels will be MC or FNs or IAWs. So this is a steel weight. So you can see how this one is centered up here. That's the first weight that it's indexing for this left side or inboard side. And so if I grab a 3/4 ounce and put it right on the laser, right down the center of this laser, and just hammer that on, then I can hit next, which most of your newer balancers have that functionality. And then it's gonna set up to center up my outboard one. So that's a 1 1/4. So I'll come out here and line it right down the center of the spindle and then hammer that one on. And then you drop your hood and make sure it zeroes out. So it zeroes out. It's within tolerance. Everything zeroes out, so we're good to go on that. And that is balancing tires.